Hi everyone, we are Group 7 and we've designed an all-terrain Mars rover. My name is Spencer Speary.
My name is Tony.
John.
And so we'd like to blast off and show you what we have for you guys. So in an age of exploration and with Purdue's really big history of innovation and space exploration and all sorts of things that are going on with technology, we wanted to give kids an outlook and an outlet to be able to do things where it was tactile and for them to play with the world around them. And so the rover that we designed is actually based on the rover Opportunity, so that kids can see something that's actually something real and then something that they can be playing with. So the toy itself is built to inspire, and it allows the kids to see exploration everywhere in the world. So it's not just one thing they have. They can take this toy anywhere, and it will be able to take all sorts of terrains, and it can bring them outside, as well as encouraging curiosity in the STEM fields and having a theme that's related to science and space.
So some of the key features that we have for our Mars rovers, first of all, it has all-terrain capabilities, as we stated previously, and also it has built-in suspensions. It's powered by 6 DC motors and 6 wheels, and it will be piloted by a PlayStation controller. So the background and the target audience is, so first of all, this project is inspired by the Mars rover design with some of the research that we did with Rocket Bogey. And kids loves toys, and especially those that has wheels that can drive around, like for the boys. And also kids loves to go outside and explore. So with this Mars rover toy, they can go anywhere with this. So some of the benchmark analysis we did, we investigated with our competitors, so the Hot Wheels and also this build-yourself kit. And none of them has the Rocket Bogey characteristics, and I just think ours will be a better competitor in the market once it's released. Some of the key mechanism it has, first of all, the Rocket Bogey. The front wheels is pivoted to match the all-terrain, and also this Rocket Bogey mechanism can allow all 6 wheels at any time, any terrains, it will stay touch with the ground. And the rover, we haven't done it yet, but the head can adjust its angles with our PlayStation controller. So some of the prototyping we did, so we use laser cutting and also 3D printing. Our laser cutting is 1/8 of an inch thick plywood, and it's designed to account for the laser thickness and the tolerance of the laser cutting. And for 3D printing, we use FDM for both using the TAS6 and also the IronStar 3D printer. And we designed it to take into account for the non-isotropic behavior, and we adjusted to reduce the print time and also the material waste.
So the design of the Rocket Bogey, we actually made the legs of it using laser cutting, like Tony was just saying. We have a bunch of holes throughout the entire leg system. This is to account for any rapid design changes we might want to make. This is also to reduce the weight of the legs and overall just make it have some design on the legs and not just be plain. So the chassis, as you can see, hopefully, maybe, we kind of designed all of the pieces of the chassis to fit together kind of like in a puzzle. And we again made this using laser cutting. This was 1/8 inch thick plywood that we used. The puzzle kind of structure of the chassis made it really easy to assemble. There's actually, we're not relying on that aspect for structural support. We actually hot glued everything inside, but you can't see it from the outside. Also on the front of it, we etched in Purdue ME444 to pay homage to the class that let us build this design. Yeah.
So we'll do a demo of it controlled by the controller. We put holes in the top so you can take it off. Otherwise it gets stuck. And using the controller over the Blink app allowed us to get better feedback, and so we can even have tactile responses. So as the person is playing with it, the controller will buzz and do all sorts of things. So they can have it go forward. This side's going forward. We lost the wheel. And it'll turn. So when it's turning, the wheel's going opposite directions, as well as it will go in reverse. We adjusted the duty cycle to account for the supports were a little bit weaker than the attachments for the wheel hubs were a little bit weaker than we thought. So we adjusted the duty cycle so that they wouldn't break, but that's still a little work in progress just to account so that we don't break the parts and everything stays in line. So the remaining tasks we have going is we are going to continue playing with these duty cycles and as well as we need to finish the head that will have the servo attached to it so that can allow it to look around and have even more interaction for the person to be playing with. And there are some connections that we need to be working on for the internal electronics that we have. So thank you guys very much, and if there are any questions.
So, have you tried to let it go through some terrain, like some obstacles?
So with this, we have not actually been able to do that yet because of the wheel connections.
Okay.
Because of the FDM and the non-isotropic behavior, as we talked about, there have been some issues because we need to choose like the direction with the strength that it has, and so we need to figure that out. Better way for the connections.
Before we even started like actually designing it, we ran it through Creo, their simulation skeleton model, and it seemed like it would work just fine. But no, we haven't been able to actually test it.
Okay.
Okay.
Looking forward to seeing it actually.